Hello everyone, welcome to All About Analytics. Today we are starting our first video tutorial on data cleaning, data pre-processing, or you can say it also data cleansing. In this tutorial you will learn how to handle missing values and missing value imputation techniques. Okay, so let's start it. So for cleaning the dataset we use some certain techniques. The first technique is ignore all the missing values from the dataset, right? And which means delete or drop all those rows with NN values from the dataset. Second method is fill missing values manually. Instead of NN, you can insert some global constant like not define or value missing etc. in place of NN. Third method is measure of central tendency. So in measure of central tendency, what we do is we select our column with missing data and find that column's mean and replace the NaN value with the mean value of their respective columns. You can also use median value instead of means. And the third method is measure of central tendency for each class. As you can see, I have given a small description of data in right side. In this dataset, we are having column product name, which is having different classes like toothpaste, shirt, etc. So in this case, when we will fill the NN values of price column, we will do it by using their class. For example, if we are removing the NN values of shirt class, then we will find out the mean or median of shirt class and replace all those NN values with mean or median of shirt class. The fifth method is fill missing values using machine learning algorithms, for example, like SK, learn library, simple imputer, etc. Okay, so let's start our first tutorial on handling missing values. So in this tutorial, we will use the first method of ignoring. How can we ignore the NaN values, right? So for that, I'm using a data set, house price prediction, which is available on kaggle.com. I'm also providing the link of the dataset on my on the description of the video. So let's start it. First of all, we need to import the libraries. Import pandas as pd, import matplotlib, import matplotlib .python as plt, import seaborn as sns, right? Now I have already copied the path of the dataset, so let's convert this dataset into a data frame. So for doing this, we have a function in pandas pd.read underscore csv. The dataset which we have is in csv format, so that's why I'm using the csv function. So path, I'm giving the path name inside the bracket, and now I'm giving this data set to a variable called data, right? Now if I wanted to check the data, what I have to do is just write data and execute the program. It's taking some time, so we have to wait and keep patience. Okay, so as you can see, this is the whole data game. If we check the shape of our data, actually this computer is too slow. Okay, if we check the shape of our data, that our data has contained almost 81 columns. Data dot shape, right? Okay, our data has 80 columns and 1459 rows. So in So let's check the first 5 rows of our dataset. Data.head. So this will show all the first 5 rows of our dataset with all the columns. So these are the 80 columns. In some cases, sometimes when we check for our dataset, so it doesn't show the whole columns. For example, if we are having 100 column or 18 90 columns, so our data set, when we apply when we wanted to see the data set, it doesn't show all the columns. So for doing that, what we have to do is we have to use a function called pd.set_options, in which you have to display all the rows or all the columns. Okay, so you can use that function if in case it is not showing whole column in your system, right? So now what I have to do is I wanted to plot a heat map which will show that how much impurity does my dataset contains. So how I will check that? I will use a n function. I will use a plot sns.heatmap. sns.heatmap. In this heat map, what I will do is I will plot data.isNull. This will show me all the impurities in my data set through a visualization. Okay, this figure's size is too less, so let's make it like plt.figure fig size equal to 20, right? Yes. So as you can see, now the figure size has been improved. So all these white spots which you can see in our dataset, these are the missing values which we have to remove, right? See this one. So here it is showing that pool QC column, fence column, missing miscellaneous features column are having missing values, right? Here when we come here, fireplace Q column, garage type has missing values, garage call have missing values, and here alley is having missing values. All these columns are having missing values. So now what I will do is I will check for the day. I'll check all the columns and check whether if that how much percentage of data is missing from each column, right? First we have to check this. So for checking how much percentage of data is missing, we will check it like this: data dot is null dot mean into 100. So this will show you the percentage, that how much percentage of data is missing. So here you can see in lot frontage we have 15% of data missing. Here you can see in LA 92% of data missing. So I think we should delete this column. If 92% of data of this column is missing, so obviously we have to delete this column, right? Or here you can see in mass Vienna type we have 1% data missing. Here BSMT call data and others. So it will show all the columns with how much percentage of values are missing in that. Okay, here you can see in pool QC, fence and miscellaneous features, all these have 99. This one also have to be deleted. This one is also have to be deleted. Miscellaneous features column, we have to also delete this column, right? So what I'm doing is I will delete all the columns which are having missing values greater than 20%, right? So I'm deleting all these columns. So for doing this, what we have to do is I'm saving this missing columns, missing percentage, and miss underscore per. I'm saving this percentage data inside a variable called miss underscore per. And now I will select out the columns which are having greater than which are having data missing greater than 20%, right? So miss underscore underscore per greater than 20 dot keys means we want its columns keys. And now I'm giving the variable name, which these are the columns which I wanted to drop, right? So I'm giving it drop underscore column. Invalid orientation error. Oh, sorry. Here I put the dot. Okay, give a minute. Now it will shows us columns, right? Now check what are the columns which are having greater than 20% missing values, right? So these are the columns which are having more than 20% missing data, right? So what I will do is I will delete these columns, drop. So for dropping these values we have to use data dot drop, right? So inside this we have to pass an argument columns equal to a list of columns, right? So instead of passing a list, I'm using this variable, sorry, this variable drop underscore column. These are the columns which I wanted to drop, right? And then I wanted to save rest of the data in data 1 variable. So now let's check for data 1 dot head, sorry, not dot head. Now we will check the shape of the data. There must be some reduction in shape. So as you can see here, it is showing 75 columns. Before we was having 80 columns. It means we have deleted 5 columns. So as we have see, now let's again plot the SNS plot, sorry, heat map plot, to check that how much changes have came in our data set, right? So SNS dot heat map data 1 dot as null. So as you can see, there are less number of white spots, which means we have deleted all those columns which are showing here. As you can see, these are the missing values which was present. Almost 90% of data is missing. So what we have did, what I've did, that all those columns, I have deleted all those columns which are having missing values greater than 20%, right? Now as you can see, our data set is still having some null values. So now we have to remove all those NaN values, right? So how we will do it? We will do it like, we will select out the data. Now what we will do is I will drop all those rows which are having missing values, right? So data 1 dot drop NA. NA means we are dropping rows, right? Data dot drop NA, and we will save this into a variable. df, so I'm naming this as data2, right? Data dot drop in. Now let's check our data dot is null dot sum. Sorry, I have written the old data set here, data2 dot is null dot sum. So here you can see that it is showing all missing values are onto 0. It means our data set is clean now. So let's plot and visualize that and check that our data set is clean or not. Is it still having some white spots in data set, or it is clean, right? So for doing this, let's fix the size of the data set first. Field dot sorry, not data set size, it's figure size. Data plt dot figure function fix size equal to 20 comma 20. sns dot heat map, right? Now what we have to do is data 2 dot is null. This will give us a heat map plot which is completely non-spotted, right? So this means our data is almost clean. As you can see, there is no spot anymore, though there is no any more white spot present in the dataset. So here, as you can see, the pink color's value is 0. So it means that our dataset is clean. So in this tutorial, we have learned that how we can ignore the missing values and how we can delete the rows and columns which is having dataset, which is having NaN values in our dataset, right? So in next tutorial, what we will learn is how to fill these missing values manually, and then we will switch on to measure of central tendency and then measure of central tendency for each class, and then we will learn that how we can improve our missing value imputation through machine learning algorithms, right? So thank you for watching, and meet you on the next tutorial. Thank you so much.